multiplying, distributing, we'll talk about what that is, and simplifying polynomials. So I have a very long question. Hopefully you don't have to deal with anything this long. But the reason I've made it so long is just so that we essentially go over every single one of these little things and you can see all the different types of examples. We talked about before how the plus signs and subtraction signs, they separate terms. So you can literally think of this as like one term. It's eventually going to break off once we get into our brackets. But think of this when you start just as a term and you have to distribute. And to distribute just means you have a 2 outside of a set of brackets. That actually means multiply. But because there's 2 terms in the brackets, you're going to multiply by each of those terms. So essentially what's going to happen is we're going to do that over and over and over again, 4 different times. We're going to take the value, whatever's in front of the brackets, and multiply by each of the terms inside the brackets, okay? So, to start with the very first one, we have 2 times x. I'm going to write an equal sign in on the left so we just get used to it, okay? 2 times x is just going to give us 2x, okay? 2 times negative 3, that's going to give me negative 6. So great, I've done that part. Now we're moving on to the second part here. So this second part has a plus sign. Well, you can actually think of that like there's a positive 1 here. And I'm going to multiply positive 1 by each of the terms, okay? Luckily, that's really easy to do. 1 times 6 is just 6. And 1 times negative y is just negative y. Great. Third one. The third one here is a little trickier. You'll notice the third one here has a variable, and it has a coefficient that has a negative. So we have to remember to multiply that negative in, okay? So negative 3x times 4, well, there's no exponent here. So sorry, not exponent, no variable here. So the variable is going to stay the same. It's still going to be x. But we are going to multiply the 4 times the negative 3. So 4 times negative 3 is actually negative 12. And I just write the x in after that. Okay, so that one is a little tricky. But maybe it'll make more sense at the very end here. Here, notice that I just have a negative. Again, I can just put a 1 in. But positive 1 and negative 1 are a little different. When we multiply positive 1 or negative 1, forgot to write these little rainbows in, sorry.
Sorry.
Negative 1 is going to change our values. So negative 1 times 2 actually gives me negative 2. And negative 1 times y gives me negative y. So you'll notice the 2 terms in there, they actually flip their operations. So that's a really quick way. If you just have a negative, it's the same absolute value, so what the terms are, but you just switch the operation in front of them, okay?
Okay.
That's distributive and technically multiplying. We've done those 2 steps. The next thing we've got to work on is simplifying. To simplify, we need to collect our like terms. So like we did before, we're going to kind of highlight things here. I got a 2x. Oh, I feel like I missed something here. I did. I knew it. I multiplied this by this value, but I never multiplied it by the x. So I'm going to... Oops. That's not working. There we go. I'm going to add those in. Thank goodness I realized that. We did negative 3x times 4. We got that value. We forgot to do negative 3x times x. The coefficient here is a 1. So 1 times negative 3 is still going to be negative 3. But x times x, do you know what that ends up going to be?
X times x?
Yeah. You actually end up adding the 2 exponents. Because there's a power of 1 and a power of 1 there.
Yeah, would it be x squared?
Yeah, that's the power of 2. Great. And then we're going to write the other 2 in. I thought something was missing here. Good. I do not remember why I underlined that, so I'm going to take it out. So we're going to collect like terms. So we have 2x. We're going to look for other variables of x to the power of 1. Do you see any?
For x, 12x?
Yeah, and it's not just 12. Make sure you get that negative in there. Because that negative is going to let you know that you actually have to take 2x and subtract 12x from it. Okay, so remember, keep that in mind. The next major variable I see is a y. We'll do it in blue. I see a y variable. Do you see any other y variables?
I see the negative y.
Yeah, negative y. Now here's interesting. How about negative 6? Any other like terms for negative 6? Because it doesn't have a variable.
Positive?
Yeah, positive 6. So anything that doesn't have a variable, those are essentially constants. Any other constants you see?
Negative 2.
Negative 2, great. We'll put that together. And then finally, we do have one. I run out of colors. 1, 2, 3. Oh, yellow. There we go. This one's going to kind of be by itself, so I'll leave that till the end. So let's start our next line. Oh, I always do that. Our next line here. I'm going to group our like terms. So in green we had 2x and negative 12x. I'll put those together, okay? My constants, I had negative 6 or minus 6, plus 6, and minus 2 or negative 2, however you want to read it. We then had minus y or subtract y. And then finally we had negative 3x squared. I'm going to rewrite it all in black so it's a little easier to see. So we've grouped our like terms. Now we actually have to simplify them all. Yep. Minus y. There's a lot to this question. Okay. The first set. Negative 2x minus 12x. We just look at the coefficients. So, sorry, positive 2x minus 12x. This is 2 minus 12, so that's going to give us negative. Yeah. Perfect. I have 3 terms here. What's really neat about them is that negative 6 and positive 6, they cancel each other out. So we're just left with negative 2. So think of that as subtract 2 or negative 2. Blue. Y's. Negative y minus y. It's a little harder because I don't see any coefficients. Remember that there's always a 1 there. So think of it as negative 1 minus 1. And that's actually going to give you negative 2, and then there's going to be a y. So you're combining the two negatives together, so you have 2 negative y's, okay? And finally, the last term, there's nothing to group it with, nothing to simplify it with, so it just stays the way it is. And I'll just write them a little closer together. One thing your teacher might want you to do is it's common with polynomials, that's what this type of math relation is to write the one with the largest exponent farthest to the left. Just because in English we read left to right, they want to see the biggest values first. So they may ask you to put this one all the way to the left. So there's a negative in front of it, so when we move it, it's negative 3x squared. From there, we tend to go in alphabetical order. So the next one is actually an x, not the y, okay? So then I'm going to write negative 10x. Now, then I still have a variable, a y, so minus 2y. And then finally, we end with our constant negative 2. Mathematically, in terms of calculating, there's no difference between this line and this line. This is sometimes teachers like format, like you had before, so they may ask you to order it. Okay?
I should have a question.
Yeah.
So for over here.
This part? Yeah.
Yeah. What? Because there's a plus there, right? So wouldn't it be 12, negative 12 plus?
So, quick question. You could say that it's negative 12 plus negative 3x, but do you know the rules for multiplying integers? So like a positive times a positive equals a positive, a negative times a negative.
For multiplying, yeah.
Yeah, is a positive, and a negative times a positive is a negative. So, I'm going to write this in after the fact, okay? So that plus there, think of it like the plus comes in here, okay? We have 2 integers beside each other with no numbers. That could be really confusing to look at. So a way to simplify them is to look at these rules. And since they're right beside each other, how can I take 2 of them and turn them into 1? Well, if I were to have like 3 plus 3, I can just write that as 3 plus 3 because 2 pluses become that. If I end up with 3 subtract negative 3, that's how you get that. I can simplify that by actually writing 3 plus 3 again. Notice this rule turns them into a positive, okay? Finally, if we have something like 3 subtract positive 3, well, if we look at our operations for multiplication, that actually just turns into a 3 minus 3. So in this case, I took out this plus and just left the minus sign there, okay? I know that can be really tricky. If you prefer writing it this way, where you have 2 operations beside each other, that's fine. But you may want to always simplify after because it can be really difficult to figure out that 3 subtract a negative 3. It can be visually hard to look at, okay? If you run into any issues with it, I'll help you try to simplify that part.